Hello everyone. In this video tutorial, we will be learning about SQL joins. So far, all the select statements that we have executed were based on a single table. If you review the previous video tutorials, you will note that most of the select statement that we had executed were targeted at the employees table. But I'm sure you remember from the video lecture we created the HR schema. We have several tables in our schema, and in real time also you're going to work with several tables. So basically, when we are designing the database, when we are normalizing our database, we're going to end up with several related tables. Now, for reporting purpose, time and again, we are going to have the requirement of summarizing data or fetching data from more than one table. Take example of a bank statement that you received in your email or through post. If you look at the bank statement, there will be the branch address of the bank. There will be your account details. There will be maybe your name, address, and then there'll be transaction details, all the transactions you did, in a given period. So that is one report. All the data that you're seeing on that report is not necessarily coming from a single table. That data represented in that report, in that bank statement, is basically fetched from multiple tables and it is summarized into one place. So in real time, we are going to have a frequent requirement of fetching data that is distributed across multiple tables. And whenever we want to fetch data, whenever we want to retrieve data from multiple tables, we have to join the tables. Let us first understand our data and then we will start writing the SQL code. What I have done is I have retrieved the data from the departments table, employee table, and salary table, and I have copied it into an Excel file. This is just so that you understand the data. This is not required, okay, to be done. I am just giving you a high level snapshot of the entire data so that you understand what we are doing. So we have department table that has department number and it has 4 records, 10, 20, 30, 40 with department name and location. Then we have employees table and it has about 15 records, I believe. Okay. And you will see that we have a department number column. Now assume I want to list the name of the employee number name, job, department number, and department name and location in one report. I want to know the name of each employee's department and the location of each employee. Now, this information that I need is spread across two tables. And in order to get that data, I will have to join these two tables. For example, let us say you want a list of all employees working in Dallas, or you want a list of all employees working in Boston. So Boston is stored here or Chicago is stored here. And then we need to basically relate this column with this column and then fetch the data. Let me do a manual task. If I ask you, can you tell me the department name of employee Smith? If I ask you, what department name does employee Smith works in? Your answer should be research. If I ask you, what what city does employee Alan works in? I want to know the location of employee Alan. Your answer should be employee Alan works in Chicago. So what is the logic? What logic are we doing here? We are taking an employee's department number and then we are matching that with department tables department number. Am I correct, guys? So when I ask you these questions and if you were able to answer them, the logic was that when I asked you what department name Smith works in, you went to Smith, you saw that Smith works in department 20, and then we related that, okay, department 20 is research. When I asked you what is the location of employee Allen, you noted that employee Allen works in department 30 and department 30 is located in Chicago. So what was the manual logic that we applied in our mind? We went to employees table and we took the department number column value and we matched it. We manually matched it in our minds with the department table's department number. Now remember this part, okay? Remember this part. This will form the basis of our join query later on. Let me start by selecting these 5 columns: employee number, name, job, department number, and then department name and location. Let me start by writing a select statement with these columns. If you can't remember the column names, you can always expand the table from here and you can see the exact column names. Now I do remember the column names, so I'm going to just write it. Select now employee number, e-name, job, department number, department name, and location. Now remember, up until now, we were only selecting from one table, employee, but now we are selecting from employee as well as department. We are selecting from 2 different tables. So in such scenario, it is beneficial and in some cases even mandatory to prefix the table name with column name. So we want to tell the database exactly which table the column belongs to. So these columns belongs to what? The employees table. I'm going to do a slight change. I will basically select department number from departments table. Okay, I'm going to just select it from that table instead of here. So I want the department number value to come from the departments table. Same way I want the department name from departments table and the location from departments table. And what we are doing now is we are basically selecting from 2 different tables like this. Now remember, employee table has 15 records and department table has 4 records. When I run this statement, have a look at the output. There are 60 records in the output. Whereas in employee table, we actually have how many records? We only have 15 records. So can you put that into an equation? 15 records, 4 records, and then 60. What is the equation? 15 multiplied by 4 gives you 60. So right now, the output that we are seeing, this output is called as a cross join or even called as a Cartesian product. This is useless. This is incorrect. I just wanted you to see this output. This is never useful. If you have studied set theory or matrices in mathematics, what is happening right now? All elements of set A are getting multiplied with all elements of set B. For example, have a look here, guys. So these are the 15 employees that we have. And if you look at them, all 15 employees are appearing once with department 10. Then again, if you see Smith is the first employee, okay? At the top, have a look. Smith is the first employee. Then again, it is starting Smith. And again, it is, repeating again with department 20. And again, if you see the first record here is Smith, then again, it is repeating with department 30. And same way, you will see that it repeats with department 40 also. So what is happening right now is the database is picking this record and it is displaying it 4 times, once for each of the department number. And this is called as a cross join or a Cartesian product. This is incorrect, invalid, and useless. We need to stop this from happening. We want that if Smith record belongs to department 20, then only department 20's name and department 20's location should appear with Smith. If Miller belongs to department number 10, then only department 10's department name and department 10's location should appear with Miller. And to achieve that, we will do this, what we have already discussed. In my query, in my statement, I'm going to rewrite this now the correct way. The earlier one is not the correct one. I'm now going to write join, and then I'm going to say a condition. I want the tables to be joined, but that join should happen only when a condition is met. And that condition is what we already have written, that join the records only when the department numbers are matching. An employee's department number should match department's department number. Writing this join condition is the heart of the logic. It's the most important part of your logic. I again go back to the Excel sheet so that you remember when we were doing that manual search, we did the same thing, guys. Now, what this join condition does, it will pick up, let me take this record, Martin's record. Okay, it will pick up Martin's record and then it will go to department's table. Martin is in department 30. It will check. Does 30 equal to 10? No. So Martin's record will not appear with department 10. Then again it will check. Does 30 equals 20? Again false. So Martin's record will not appear with research and Dallas. 30 equals 30? True. So Martin's record will appear with sales and Chicago. And again 30 equals 40? False. So Martin's record will not appear with operations and Boston. So this way, only when the department numbers match, the department name and location will be selected, or else when they don't match, it will be discarded. I'm going to come back to this select statement and let me run this select statement now and have a look. Now I have 14 records. There are 15 records in employee table, but if you note, the last record, there is no department number. It is null. So it will not become part of the output. And we will discuss about it later in the video lecture. For now, the 14 employees that have a department number, they are appearing in the output. And just to make the output more, easy to understand, I'm going to simply do order by the department number column, just to make it simpler for us, okay? So I'm going to run this and have a look. So department 10, names and locations. After that, department 20, names and locations. And lastly, department 30, names and locations. This is the most important, most widely used join. We call this inner join. There are different types of join, and we are starting with the first one, inner join. Writing this join condition is important, because if you don't write the join condition, then what happens? I'm going to simply remove this condition. I'm going to simply remove this condition and show it to you once again. Let me run this. Okay, so I'm going to remove this as well. Run this, and what happens? Okay, so when I write the keyword join, I have to write the condition, it seems. So I'm going to run this part. When I don't write the join condition, it will be a cross product. This is useless. By the way, I can also write cross join here like this. Okay. I can also write cross join. The output will be same. But this is useless output, okay? Now, inner joins are the default joins. That's why I didn't have to write the keyword inner here. But if you want to write the keyword inner, you can write, okay? But even if you don't write, it's the default. It's the default join. This inner join will be our basis of understanding all the other joins, okay? So the first join that we are going to see or did we discuss was a cross join, which is useless, incorrect. The second join is the inner join, which is the default and the most commonly used. So when you don't specify the join, it will be a inner join. There are a few more joins that we will discuss in a while. But our inner join will be the basis of understanding all the other joins. Of course, writing order by is entirely optional. I'm just doing it to arrange the output. There you go. Now, let us say if the question was, okay, I want to know, find the, let us say, clerk working at Chicago location. Okay. So now I want to know who is the clerk that works at Chicago location. So now to get the output, I need to join two tables, which I am already doing, but that's not it. I don't want all the data. I want to put additional conditions and I can do that. I can say where employee dot department number, employee dot job equals to what? Clerk. But again, if I just run this, it will show me clerk working on all the locations. I am only interested in the clerk who works in Chicago. So I can say again, and department table dot location equals to Chicago. Let us run this and have a look. So you can always add additional conditions as needed. Okay. I'm going to give you this statement as well. A lot of your lab questions will require you to do this. The approach should be that you first identify the tables that the data needs to come from. You first join the tables and then you one by one you add one condition and then you see how the data changes. So this is inner join. Now in inner join, if you are using the comparison operator equals, it is also called as a equi-join. Okay. We will also see an example of a non-equi-join. Later on, I'll show you one more example of a non-equi-join. Now coming back to the equi-join, again, I'm going to copy this, go back. And as I was saying, I'm going to use inner join as a basis for understanding all the other joins, okay? Now remember guys, inner join will give you data that matches in both the table. Have a look at our data. I have department 10, I have department 20, and then I have department 30. And I have employees 14, okay? But if I go back to my Excel sheet where I have all the data, please note I also have department 40, which is not part of my output. Why? Because there is no employee in department number 40. Have a look. All the employees are either in 10, 20, and 30. So my inner join will exclude this 40 because it does not satisfy the join condition. Same way, I have this record of John where the department number is null and that record is also not part of the output. Why? Because John's department number is null and then the condition becomes false. The join condition becomes false. So to summarize, I have a department without employees and I have an employee without a department number. And equi-join will exclude both of these. Why? Because they don't satisfy this join condition. If you want to include those records in the output as well that do not satisfy the join condition, you can go and you can basically use something called as a outer join. The outer join can be left, right, or full outer join. Let us see that. Here, I'm going to write right. And in fact, I'm going to start with left. So on the left side, we have which table here? In the join sequence, I have the employee table on the left. Remember from the Excel, I am presently not able to get this record in the output. Okay. So when I write left, employee table is on the left. I run this record. So I think I selected only a part of the query. So I'm going to run that again. And there you go. And have a look. Have a look at the bottom, guys. Do you see the record John now? Do you see this John record? Why? Because I wrote left here. This same left, if I change it to the keyword right, on the right side, we have which table? Department table. Which record was missing from department table? The 40 operations. I'm going to come back again. I'm going to run that. Have a look at the bottom, guys. Can you see department 40 in the output now? Because I wrote the keyword right, it included all the records of the right department, even if they don't meet the join condition. And lastly, no points for guessing. If I write full, what should you expect? You should expect both department 40 and John. So when you change the keyword from inner to left, right, or full, depending on the left, right, and full keyword, it will basically first match all the records that, basically satisfy this condition. Then it will include all the remaining records from either left or right or basically full. These are called as your outer joins. So I'm going to copy this. I'm going to put it here. So this is the third type of join. First of all, they are called outer joins. They can be left, they can be right, or they can be full. And here, I'm going to write this. So left, I will in fact, just to avoid any confusion, I'll repeat it 3 times so that, there is no doubt. So left, you can do left, you can do right, or you can do a full outer join. This is your third type of join, the outer joins. I hope this Excel sheet and the data, helps you understand joins. Next, if you noted, so far I have joined only using equal to sign. Everywhere I'm joining, it is always what? Equal to, equal to, equal to. I want you to focus, now change your attention towards this table, sal grade. In the sal grade table, I have grade 1, 2, 3, 4, 5, and each grade has a range of salary. So for grade 1, the minimum or low sal is 700, the maximum or high sal is 1200. And so on, for every grade, there is a range. So now, if I ask you, to what grade does employee Jones belong to? If I want to know the grade of employee Jones, is Jones' salary in this range? Nope. Is it in this range? Again, no. Is it in this range? Again, no. Is it in this range? Yes. So employee Jones belongs to grade 4. So what was your searching logic here again, guys? You're taking the employee's salary and you're making sure that that salary is between this low sal and this high sal. So if I want to write a statement about that, can I write this? You are basically picking up an employee's salary and making sure that it is between sal grades low sal and sal grades high sal. So you are making sure that this condition is met. Am I correct, guys? You are making sure that this condition is met. And now we have to convert this same analytical approach to SQL code. Let us do that. Our requirement is list the grade of each employee. So I'm going to write select employee.ename. It's better to include the primary key always. Employee.employee number, employee.ename, employee.salary, and then salgrade.grade. So again, I know I basically remember all the column names, but if you can't recall the column names, you can always, expand the table here and check out the column name. So we want the grade column from salgrade. So salgrade.grade. From employee, join. Again, if I'm not writing anything, it's a inner join, right? Inner is the default keyword. Inner join salgrade on. In fact, I'm going to take this in the next line on employee salary between employee dot low sal, sorry, my mistake, salgrade dot low sal column and salgrade dot high sal column. Have a look at this, guys. I run this and have a look at this. These are all the employees along with their grades. These are all the employees along with their grades. Now, am I using an equal to operator here? No. So this is an example of a non-equijoin. So you're not looking for an exact match. You're not looking for an equal to, right? You're looking for a range of value. So this is possible. This kind of joins are also allowed. They are called as non-equijoin. They are also inner join. They're also a type of inner join. But instead of using equal to, you are basically here using greater than equal to and less than equal to. Between is what? Greater than equal to and less than equal to, right? Now, one a slightly different approach is in real time, you could have, really long table names and always prefixing the table name to a column could be time consuming. Let us say if you have a like really long table name, always writing that long table name before every column name could be time consuming. So one approach is I can write like this EMP and I can give any character. Let us say I'm giving E and let us say I'm giving SG for salary. Okay. This E and SG is my choice. I can write anything. Now, within this query, whenever I write E, I am referring to employee table. And whenever I write SG, I am referring to sal grade. Just like a column alias, this becomes your table alias. This is a temporary name, a temporary alternate name that we are giving to a table only for this query. This is not permanent, of course. So only for this query, SG refers to the salary table and E refers to the employee table. So this is a kind of a shortcut, I would say, to basically, uh, make the query easier to write. Output wise, there is no change. It's the same output. Let me change this question slightly to show you one more possibility. I'm gonna basically want list all the grade 3 employees. So now I want a list of all employees who are of grade 3. So again, to answer this, first I need to join. And in your lab also, you're going to have a lot of such questions. The first thing you have to do is, we know that the data will come from two tables, so join those two tables. Now I don't want all this record. I only want and sg dot grade equals to what? 3. And then I run this again and have a look. These are only these are the only grade 3 employees. So you can always add, more and more conditions. You can do all aggregate functions and group bys and havings and all those things. So there is no issue with that. I'm going to give you one small class task. You can try it later. List grade wise total salary for each grade. Right, guys? So if I go back to the previous query, I will not give you the solution. I'm just giving you this as a question to practice. So some employees are of grade 1, some are of in grade 2. Let us say I want to know what is the total salary of all grade 1 employees? What is the total salary of all grade 2 employees and so on. So here you need to first join, then do a aggregate sum, then do a group by and all that. So try this question for a practice. I'm going to leave that to you, okay? So there you go. That's a non-equijoin. Now, look at my next question. List the employees along with their department and grade details. So now I want one output that gives me all the important information of employees along with the department name and location and the grade to which they belong to. So I'm going to select employee number, rename job. I'm going to select salary. I'm going to select the department number, name, location. And I also want to select the grade of the employee. So now for this select or for this output, how many tables I need to join? I need to join 3 tables: employee, salary, grade, and department. In all of these statements, I'm basically joining 2 tables, right? So when I'm joining 2 tables, I'm writing at least one join condition. This is the join condition. Okay. When I want to join 3 tables, I must write at least 2 join conditions. Let us see that. Select. I'm going to use the shortcut D dot department number. In fact, I'm going to start with E. E dot employee number, E dot E name, E dot job, E dot salary, SG dot grade, D dot department number, D dot D name, and D dot location. You could have written all of that in one line also. I just did that for easier comprehension. From employee E, join department D on, and then the join condition. We already know the join condition. The join condition is that the department number from both the tables should match, right? The department number of department should match the department number of employee. And then again, join this output to salgrade S on. And we have already written that question. Oh, it is salgrade SG, okay? SG, I use the term SG. So E dot salary between salgrade dot low sal and salgrade dot high sal. I'm gonna in your labs and in future, you will end up joining maybe 5, 10, 20 tables. So try to kind of, format your code in a way that it makes it easy for you to comprehend, understand, and it helps in, finding the errors as well. So this is the best way of writing the code. I'm going to run this and have a look, guys. I prefer to order by the department number column. I can always write that order by also. Order by, so department number, D dot department number, okay? I prefer to do that, and there you go. So have a look here, guys. This output is coming from three tables. And I can always, when I don't write anything, it is an inner join, right, guys? It is an inner join. So I can make this a full join also. If you remember, if you want everything from department and employee, I can do a full here. Have a look here. So now what happens is I'm getting department 40. Where is department 40? Full join. Why is department 40, 10, 20? Is this nothing to do with salary? I doubt salary has any impact on that. Okay. Now I can explain you that, but it will basically take the lecture out of its scope. So I'm going to just keep one full join. I don't want to deviate the topic, but for now, it's only when you are joining multiple tables, this is the limitation for now. So let us continue with this. I'm gonna copy this and put it here. This was a question actually I gave you for practice. Now joining three tables. Okay, and this is the code. Now you have to remember a very important point. When you join two tables, like here you're joining, let us say, two tables. So you're joining two tables, employee and sal grade. So you're writing one condition. When you're joining three tables here, you're writing two conditions. So basically, when joining n tables, n minus 1 join conditions are required. This is something very important to remember and understand. So if you're joining 10 tables, minimum you need 9 join conditions. Because if you are writing, let us say if you're joining 10 tables and you are missing, you're joining 10 tables and you're writing only 8 conditions, that means at least one of the table is not part of your join. Correct, guys? So you're joining 10 tables, but the condition has only 8 conditions. That means at least one of the table is not part of the join. And then what happens to the records in that table? What we saw at the beginning, a cross join. The records of that table will multiply itself with all the, or the output basically. So that output will become the output. You will get the output, but it will be an illogical output. So that you have to remember. Is that okay? Let us move on. So I've shown you joining more than two tables as well. Now, I'm going to take an example of any equi-join, the inner join basically. So let us say this, okay? The first example, inner join. You run this. So you have the output, 14 records. We already understood this output. Now I'm gonna rewrite this. I'm gonna rewrite this in a slightly different manner, okay? First of all, I'm gonna, instead of selecting individual column, I'm gonna select all the columns. So select all the columns from employee, inner join, department on so-and-so condition, okay? I'm gonna remove this order by as well. Let me run this statement now, guys, and have a look here. So employee table has about 8 columns. Up until here, it is employee table. And then remember, department table also has the department number column. So that column is repeating in the output now because I did a select star, right? And then name and location, okay? A shortcut, a shortcut is using a keyword called as natural join. And when you write natural join, you don't even have to write this condition. I'm going to remove this condition and that's it. This is your statement. Select all the columns from employee natural join department. Now you don't have to necessarily select all the columns. You can still specify the specific columns you want. Now when I run this statement, have a look what this natural join does. Have a look. So I'm getting 14 rows, right? So it is joining. Now, this natural join keyword is doing two things automatically internally. It is automatically writing this join condition. It has noted that department table and employee table has one common column name. The common column name is department number. So it identified, okay, these two tables have a column that has the same name. So it is automatically writing this join condition, part one. The second thing it is doing is, now if you have a look, it is showing both the primary keys at the beginning, okay, department number and employee number. And now it is not showing you the department number of employee. It is automatically eliminating the repeating column. Right, guys? So it is automatically eliminating the repeating column. It is showing that repeating column only once in the output. Now you can select specific columns instead of star, okay? That is possible. This is a shortcut of joining tables, a natural join. A natural join eliminates the need of writing the join condition. But this will only work when the column names are common. So for this natural join to work, you must have the same column name in both the tables. And that is why I always recommend that when you are creating tables, let the primary key and foreign key have the same name. So I have seen some books, they follow, let us say, there's a table called product. Its primary key column will only be ID. And then in another table orders, they will write product underscore ID, right? So when it is a primary key, you're just using the column ID, but when it becomes a foreign key, you are writing, basically a table name underscore ID and something like that. So you have done a few of those labs. I personally, for those labs, that's okay, but I personally recommend using the same column name when it is a primary key and when it is a foreign key, so that you can utilize this feature of natural join. Lastly, remember, when I don't write the type of join, what is the default join? The inner join, right, guys? So when I don't write what type of join it is, it's the default is an inner join. And since you can always do a left, right, and full. So I'm going to directly do a full one, okay? I'm directly going to do a full one, but you can try out the left, right, and have a look. I can also do a full natural join. It is giving me, department number 40. Where is department number 40? Nope. So guys, I can't see the last line basically because I have a lot of recording controls anyway. So you see that department number 40 and above that you see the John where the department number is done. Okay. So you can do a left, right, and full join also using natural keyword. I'm gonna put this in the notepad. So this is a shortcut of joining called as natural join. And natural join And you can also do a natural full join. So when I'm writing full join, it is understood that you can do left and right as well. Okay. You can try it. You can try it out. So the next join I have shown you is the natural join. So natural join is not actually a category of join. It is just a keyword that is basically simplifying your join. So it's not exactly a category of join. It's just a keyword that is simplifying your join operation. I still have one more join to show you, but for that, let us go back to our data. Now, to understand this last join, you need to understand the data first. Now, the focus should be, I'm going to just remove the colors that I have used here. So, standard color, no fill, no fill. Okay, and I think I'm going to need one more statement. So, I'm going to do this. Okay, now, I want you to turn your focus to the managers, MGR column, okay? I want you to turn your focus to the manager column. Now have a look, guys. We have an employee number 7934 Miller, who is a clerk. Now this Miller has a manager, and Miller's manager number is 7782. Now the manager is also an employee, right, guys? The manager is a designation, but the manager is also an employee. If I'm working for Algonquin College, my manager is also an employee of Algonquin College. So this 7782, I'm going to just use a bit of color coding. This 7782 is actually Clark. Have a look here. Now, Clark also has a manager 7839. Now, this 7839 is King. And since King is the president, there is no manager. And same goes for all the records. Employee 7876 is Adam Clerk, and the manager for Adam Clerk is an employee 7788. And if you see, 7788 is also an employee Scott, who has another manager 7566, and 7566 is, whereas 756 is just right above, that is, Jones. And then again, Jones has manager 7839, which you already know is King. So basically, all the values that you see in the manager column are basically what? They are the employee numbers of the manager. Now, if I ask you, who is the manager of employee ward? I want you to find out the manager name of employee ward. So employee ward manager number is 7698, and 7698 is who? Blake. Make sense, guys? So what is the searching logic when I asked you who is the manager of employee ward? You took employee manager number and you matched it with the employee's employee number. Just remember this logic now. I want you to remember this part. This becomes the basis of our, next join. An employee's manager becomes an employee's manager number should match the employee number of the manager. I'm so sorry. I think I need to rephrase this. I'm going to rephrase this once again. So an employee's manager number should match manager's employee number. So again, if I go to ward manager number is 7698, and then 7698 is the employee number of that manager. So employee's manager number should match the manager's employee number. Remember this part now. Now, I want to prepare a report where I need employee name in one column and manager name in one column. So I need one column in the output that has all employee name, and I need another column in the output that has all manager names. Let us do that. Okay. Select. Now I'll write it first and explain it later. Okay. E dot employee name. So this is employee names. And M dot, again the same column, E name, but this time they will be considered manager name. From employee E, join employee M. Now, for the duration of this query's execution, there will be two copies in the memory of the employee table. One copy will be E and another copy will be M. Now that E and M is our choice. We can give any name we want. So E, we will assume has all employee names, and M is having all managers' name. Now, if I just run this, either I will get an error, or if I remove this and give a comma, so 15 records into 15, it will get multiplied that many times, okay? But we don't want this multiplication. We want that when the record of Miller is picked, with Miller, only Miller's manager name Clark should appear. When the record of Clark is picked, with Clark, only Clark's manager name King should appear. And to do that, what will we do? We will apply this condition to our join. We want that employee's manager number should be picked up and it should be matched with manager's employee number. So E is employee table, M is manager table for the duration of this query. So I'm going to write on an employee's manager number matching the manager's employee number. And I run this statement. Have a look at the output, guys. So I think we were dealing with the records Miller, Clark, and King, right? So let us go to Miller. Do we see Miller somewhere? There it is. So Miller's manager is Clark. Clark's manager is King. Did I skip something there? Miller's manager is Clark and Clark's manager is King. Yeah, so it's two lines basically. So these are, and again, we have 13 employees because we only have 13 records in the output because there are two employees where the manager is null. King manager is null. Have a look here, guys. And this Dallas, this John record also the manager is null. Okay, so out of 15, those two will not come in the output. You can always do a left join if you want to see those two records. Okay, so they will appear the like John and King without the managers, but I don't think it has any logic here, so I'm just going to keep it like this. Now, in this statement, are you joining two different tables? No. We are joining employee table to itself. This is called as a self join. Okay. This is called as a self join. And this is the last type of join that I want to discuss in this video lecture. So guys, these are the 5 types of joins. There are some minor variations possible, but this should largely cover the logic. And if you understand this well, even if you study a new way of doing it, or a new, how do I say, a new join, there is no new category of join, but a variation of join. But based on this knowledge, understanding that will become easier. I would just like to end the statement with something. Last thing, all the joins that we have written, these are called as explicit joins, meaning you are explicitly writing the keyword join. You are instructing the database to join the two tables. There is also something called as implicit join, Implicit join is basically when you implement a join condition using where clause. I'll just give you one example. So I will take the same example of this equi join, the inner join, I'm sorry, we used at the beginning, and I'm going to give it here. This same join I can implement using a where clause. I can just say like this, comma, and instead of this, I'm going to say where. So I'm not explicitly saying that I want to join employee and department. Output is same, guys. Okay, same. If you see same 14 records, output is same. So I'm not explicitly stating that I want to join employee and department, but then I'm writing a where clause where I'm writing a condition that is automatically basically internally joining the two tables. So these are called as automatic joins or implicit joins implemented through a where clause. I'm just gonna put it there in case if you wanna explore that. So this is also possible, although I'm not going to use this method, this where clause approach. I'm not going to use that, but this is also possible. Okay, these are called as the automatic join or implicit join. So, yeah, try out these things and let me know if you have any questions. Hope you enjoyed the session, all of you. See you in the next video tutorial.